So for our first example of how to model one of our situations using a function instead of just an expression. Let's look at number 2. A poster is 10 inches longer than it is wide. Find the function that models its area A in terms of its width W. Well, that means that in the end, my function is going to be written as A in terms of W. Now, I'll come back and fill that in. The poster is 10 inches longer than it is wide. So I know the area is going to be equal to length times width. But could I express length in terms of width using W's? It's what? How do I write that? 10 inches longer than it is wide. W plus 10. Now, something to keep in mind here, guys. This whole longer than and less than and shorter than, get used to writing those on the end. For adding, it doesn't make a difference, but for subtraction, that always needs to be written on the end. So if you get in the habit of doing it like that now, it'll cause a lot fewer problems later on. Okay? Can you say a lot fewer?
Not really.
Yeah. Double.
After you said
It's not a double negative. There's only one negative in it.
but it's
Is it an oxymoron?
yes.
Oh, I don't know. All right.
We're masters.
Okay, so now let's go ahead and substitute that back in. So A of W is equal to L is W plus 10 times W. And now I'll go ahead and distribute that. Gives me A of W is equal to W squared plus 10W. Now, why did we have to go through and replace this L with the W terms? Does anybody have any idea? Yeah, because it has to be terms of W. We can't have two variables in there. Now, later on, when you get to some more advanced stuff, possibly in the second year of calculus, maybe on up if you do any sort of college-level math, then you can start getting multiple variables, and you start getting stuff that looks like this. A of WL equals, but two variable parameters, yeah, we're not going to touch that at all in high school, so don't even worry about it.